Hey, welcome to this Lunar.dev demo where we're going to showcase how the Lunar AI Gateway enables full visibility and controls on top of agentic workflows, especially when those agents are utilizing MCP servers for their tasks. So in this demo, we're observing the coordinated workflow involving 3 autonomous agents, all working together to close loop on R&D tickets. First, we got the chat agent. That agent is receiving instructions from a human via Slack. Its job is to check Linear for any new or open tickets that requires attention. Then the code agent steps in. It fetches the relevant pull request from GitHub, applies the necessary code fixes, and then commits them back to GitHub. Finally, we got the documentation agent. The purpose of that agent is to generate an updated documentation based on the code changes and then publish them to GitHub. Now that we got that setup understood, we'll see that by tunneling all of those agentic traffic and tool usage via Lunar, we'll see that we can actually enforce 3 types of policies for the sake of this demo. First one is what we call an AGR exporter. This is extracting traffic logs, full traffic logs on everything that is taking place. You'll see all of that activity that is being logged and can be presented pretty easily. Then we'll define what we call custom metrics. We'll collect specific metrics when it comes to the usage and visibility around the AI usage. How many tokens has been used, the cost associated with them, which models has been used, and also the tools that were called for those specific MCP servers. Finally, we're going to apply access controls for those MCP usage. We'll define a policy that prevents those agents from accessing specific type of files within the GitHub. Okay, so now let's see in action. Asking the first agent, the chat one, to get a ticket from Linear. Based on that ticket, we're asking the second one, the code agent, to fetch the relevant PR for that ticket. There's a problem with that ticket. We're asking the agent now to provide with a fix for that ticket. He's thinking, he's doing it. And the last agent, the documentation one, we're going to ask him to provide with the documentation for that fix before applying it. Once that's done, we can see that all 3 agents have communicated with Linear, GitHub, OpenAI to perform the tasks that were given. Now let's see how that traffic reflected in the... Looking at the control plane, we can see that the 3 agents have been using GitHub, OpenAI, and Linear. We can see that the chat agent is consuming most of the traffic to OpenAI, about 70% of that traffic. But also the code agent is using OpenAI and GitHub, and also the documentation. So they're sharing the same API keys. That's the distribution of traffic. Now we can see much more metrics that we've collected, such as which LLM has been used for those tasks and how much cost associated with them. But more importantly, we can see the actual agents that we've been using and the model they've been using, as well as the tools that they requested to invoke from those dedicated MCP servers. Also the amount of calling that they've made. So we can see also the distribution over a timeline, which agent requested which tool at which point in time. And there's much more data we can collect, but we want to show you actually how we've enforced that metrics collection policy, or which we call a flow. So going to the Lunar Flow Builder, we can see that there's an OpenAI visibility flow. And within that flow, we've defined that we want to collect a lot of metrics when it comes to the communication with OpenAI. We want to collect the total tokens that are being used, basically just an extraction from the response body, and also the model that we've been using. This is can be extracted from the body of an API request to OpenAI. There's also the traffic recorder that will provide us much more data into each and every interaction that was made. We already enforced it, as you can see. We'll revert back to it later. The AGR exporter. We'll see it in the end of the demo. And now let's enforce an actual endpoint access. So we want to basically prevent some of those API calls to be made by the agents. So we're going to say that for GitHub, we want to block specific API calls by agents. We want to assure that if an agent is accessing something that is not permitted, he will get a generated response by us. For the sake of the demo, we'll say that each and every API call to GitHub that is fetching a YAML file, so it got the suffix of a YAML file, we're gonna block it. By blocking it, basically we're gonna say that we're gonna invoke and generate a response back. Keep in mind that before that, we've seen the agent actually making an API call to fetch the specific YAML file ticket. If that agent will be making the same API call again to the MCP server of GitHub, we want to say that for the specific agent, which is the code agent, we'll provide with a response of a 403 of forbidden access, preventing him with accessing any YAML file in GitHub. Now we're going to enforce that flow. Basically, that's a generated flow, and we'll see that the policy that was easily configured by the flow builder is basically mapped into a YAML file. So it's an access flow, and we can see that it's only associated with GitHub, and we're preventing only the code agent to accessing any YAML file out there, and collecting much more labels and collecting much more metrics that we can understand on top of it. Now let's enforce that policy. Easily just dragging it into the flows section within the gateway, running that policy. And it's loaded. So now let's once again ask the agent to fetch us the linear ticket, and then based on that ticket, let's ask the code agent, to get from linear that specific ticket, that specific PR, which is a YAML file PR. And now we'll see that as opposed to the beginning of the demo, now we're seeing that the agent is saying, listen, I've encountered an error fetching the scenario YAML file from GitHub. This is because we've enforced an access control on top of the gateway that shows exactly that. Here you can see the AJR recording that we've made to actually see each and every sequence of event taking place over that traffic from all agents. So we can see there's a lot of communication with completions, the completions endpoint of OpenAI, but basically a thorough drill down of each and every tool that was invoked, when did we invoke it, a lot of data and log collection that can give you a thorough understanding of what is taking place with all of those agents communicating with both MCP servers and the LLM that they're using. That was just a glimpse around the type of controls that users can enforce on their agentic traffic and MCP usage. We've just shown you how to utilize the endpoint access, AJR exporter, and the custom metrics. However, there's much more that you can do with the system, such as rate limiting, defining a retry policy, creating a fallback between models, sanitation of data that are being sent in prompts or tool usage, as well as transforming the actual API call, creating it asynchronously, and much more. Stay tuned for more features to come, and thank you for your time.